Well, so we are now in section 5 of chapter 1. And as I promised in the tail end of that last video, I will again show you an application of some of the stuff that you've been using. Now, don't get me wrong, I am not a chemistry professor or chemist by any stretch of the imagination, although I do like chemists. In fact, many of my best friends are made of chemicals. That was a joke. I'll be honest, I stole that from Neil deGrasse Tyson, but it's still funny. Anyway, the idea is, if you have had any exposure to chemistry, that you would have undoubtedly ran into a scenario where you had to balance chemical equations, right? So chemical equations, just describe, substances consumed or produced by reactions, right? By chemical reactions. Now, the idea of saying being able to balance a chemical equation is by finding the correct number of specific atoms on so on the left side to match those corresponding atoms on the right side, right? So that's the idea. Now, I don't know how, again, just assuming that you have had some exposure to this, I don't know how your chemistry teacher taught you how to balance chemical equations, but I can recall it really amounted to guesswork. It was kind of trial and error and guesswork. Now, what I want to do is I want to show you, quite amazingly, how you can create a systematic way of solving these chemical equations without all the guesswork. What is to rescue? Yes, indeed, a matrix. So, how are we going to do this? Well, the first thing we're going to do, and I'm only going to show you this once, so I'll kind of try to do some steps here. So the first thing we're going to do is we're going to add some variables to each of these terms, right? So we got, say, x sub 1 is going to be attached to this first term, which is propane. And then we're going to attach x sub 2, another variable, to the second term, which is oxygen, O2. And then what I'm going to do, I do need to make this smaller so I have enough room to write the entire chemical reaction. And then, so we have attached x sub 1 here. We've attached x sub 2 here. We are going to go ahead and state this as an equation. So this is must equal. And you kind of guessed it, we're going to attach a variable to the carbon dioxide term, CO2, and finally a fourth variable is going to be attached to the term H2O. All right, so at this stage, all we have done is attached different variables here. Okay, so what we want to do now is we want to write each term as a vector. So we want to write each term as a column vector. Now, the vector, the way I'm gonna set it up is, so I'm gonna look at my reaction here, and it appears that my chemical equation is dealing with carbon atoms, hydrogen atoms, and oxygen atoms, right? So the column vector is going to look something like carbon atoms, hydrogen atoms, oxygen atoms. So probably one of your, on your first, second test, I guess I should say, is going to be, half the test will be applications. And there'll be an application like this, to which I will state that you must solve it using a linear system. So even if you do know the tricks or techniques that you learned from your chemistry teachers, that's not going to help you to get to do well in this question, because I want to see it done as a system. Okay, so let's go ahead, and now we're going to take each of these terms and write it as a column vector. So think about that first term. That first term has 3 carbon atoms, 8 hydrogen atoms, but 0 oxygen atoms. Right? So it's going to look like this. So we have x sub 1 multiplied by, ready? So here we go. Looking at propane, I got 3 carbons, 8 hydrogens, no oxygens. All right, plus x sub 2. And now let's look at the next term. So here I have O2. I just have 2 oxygen atoms, but I have 0 carbon atoms. I have 0 hydrogen atoms, and of course 2. I started to use the yellow color. Let me continue. So 0, 0, 2. All right, equals, and now at this stage, you pretty much see the pattern. So carbon dioxide will have 1 carbon, no hydrogens, 2 oxygens. And finally, we have water, which has 0 carbons, 2 hydrogens, and 1 oxygen. All right, so hopefully you're okay with how we have gone from here to here. And now what we're going to do is we're going to set the equation equal to 0. All right, so just to make sure you understand, I'm gonna write this in just a second, but I want you to, first off, I want you to just follow my stylus so you can understand. So when we set this equal to 0, I'm going to be grabbing this term and bring it to the left side. I'm going to be grabbing this term and bringing it to the left side of the equation. But you and I know that the signs must change, or in other words, the only way to balance this is to subtract this from both sides. So instead of having the negative symbol out here, the negative symbol is going to be here. Okay? Now, I do understand, like, if you're trying to find context, like, how would I understand if atoms can neither be created nor destroyed in a reaction, then how the heck do I have negative? Well, again, the math works. Whether you can find a proper analogy to explain is quite irrelevant, but let me go ahead and do that now. So nothing is going to change with these guys right here. So let me copy that and paste it. And let me just clean this up. So now what we're going to do is we're going to bring this x sub 3 term to the left side of the equation. And again, we're going to change our signs, but the signs are going to be changed inside of the vector. So plus x sub 3. And now it's going to be, instead of 1, it's going to be negative 1. Of course, there's no need having a negative in front of the 0. but it is going to be a negative 2. All right, again, we're going to grab that x sub 4 term. And we're going to bring that to the left side. And again, the sign changes, but we're going to let the sign change inside the vector. So for x sub 4, we have negative 2, negative 1. All right, and now we have it equal to 0, but again, we don't want to write 0. We want to write 0 in the context of this problem. So since we're dealing with 3 by 1 vectors, we want to write 0 in the context of a 3 by 1 vector. All right. Now, at this stage, we are going to, well, hopefully you can start to see where we're going to be going with this. We're trying to get to an augmented matrix. So that's going to mean that, if once we get to an augmented matrix, then we can let our technology row reduce that matrix to solve it for us, right? So to do that, we're going to, I'll just put it this way. These vectors are going to make up the columns, with this last column being, being the 0 vector. I don't want to just jump to that really quickly because I've seen students, I don't know, it just starts to look too gimmicky for students. So let me see if I can, So on the next page, I'm going to take just a little short step that you don't have to do on your test, but it is more or less just to help explain the reasoning. So you can imagine distributing this scalar, right? This weight into each of these vectors. That's what I have here. And now what you can do, and now you'll be able to see why you could have skipped this step, but the matrix that's going to be created is going to be made up of the coefficients attached to those weights. So the matrix looks like this. I'll go column by column. So 3, 8, 0, 0, 0, 2, negative 1, 0, negative 2, 0, negative 2, negative 1. All right, so now that makes up our coefficient matrix. Let's go ahead and we'll use this vertical line to make it distinct between which column has the solution and which column is the coefficients of the variables. But now we have our augmented matrix, okay? And again, this is just we have 3 rows, right? So 1, 2, 3 rows, and 1, 2, 3, 4, 5 columns. So this is a 3 by 5 matrix. Now, you should have, hopefully you have guessed where we're going after this. So when in doubt in calculus class, take a derivative. When in doubt in a linear algebra class, RREF, right? Row, reduce, echelon form. So at that point, this is what our matrix is going to look like. So let's assume that we've already let our calculator do all that row reduction. We have 0, 1, 0. Just bear with me. Let me write what we should be looking at. And then we have negative 1/4, negative 5/4, negative 3/4. So let me make sure you're with me. So we still have a 3 by 5 matrix. So 1, 2, 3, 4, 5 columns, 1, 2, 3 rows. Notice that we have 3 pivots, but this fourth column is not a pivot column, is it, right? So that, if you recall, that should translate into free variables. But at this stage, now that we've let our calculator do all of that lifting, let's write our solution, the general solution. And as you recall, I'm not going to do this here, but remember that this is the x sub 1, this is the x sub 1 column, the x sub 2, x sub 3 column, x sub 4 column. So as you recall, when we write the general solution, we solve for the basic variables. So this is a 1, meaning 1 x sub 1. Let me go ahead and write it. So this is our system. So we have x sub 1 is equal to, I'll tell you what, just for you, I'll go ahead and write it. So x sub 1 minus 1/4 x sub 4 equals 0. X sub 2 minus 5/4 x sub 4 equals 0. X sub 3 is equal to negative 3/4. I'm sorry, I put equal. X sub 3 minus 3/4 x sub 4 is equal to 0. So this little step right here, again, is optional. You could skip it. But hopefully now you can see how I can solve for the basic variables, right? So if I want to get x sub 1 as a basic variable, so I want to get that by itself, that means I just got to bring this negative 1/4 x sub 4 to the right side. So now let's finally get, that's not the general solution. That was my step to help you get to the general solution. And let me now get you to that general solution. So once I solve for my basic variables, I have x sub 1 is equal to 1/4 x sub 4. X sub 2 is equal to 5/4 x sub 4. X sub 3 is equal to 3/4 x sub 4. But do you recall what we say about x sub 4? Right, so this is a pivot column, pivot column, pivot column. This is a basic variable, basic variable, basic variable. But this is not a pivot column. This is a free variable. So when you write your general solution, you must say x sub 4 is free. It is a free variable. And that tells me that I am free to choose whatever I would like for x sub 4. Now, how the heck does this get us to a solution? Well, there's infinitely many solutions to balance that equation. But what you're going to need to do is, at this stage, you have to pick an x sub 4. Right? Because x sub 4 is free. Now, as soon as you pick an x sub 4, you can plug that in here, and I'll tell you what x sub 1 is. And I'll plug that in here, and I'll tell you what x sub 2 is. But you must choose an x sub 4. Now, again, so I'm just going to choose the smallest whole number. All right, so we don't want to talk about a half of an atom. So I will choose 4. And that's just simply, I chose 4 because, well, look at the denominators. The denominators are all 4. So that should make my math easier. So at this stage, let me give myself a little bit of space here. So I have chosen x sub my free variable. I've chosen that to be 4. Let me now answer the question. So x sub 1 is going to be equal to 1/4 times 4. X sub 2 is equal to 5/4 times 4. X sub 3 is equal to 3/4 times 4. All right, so let's do that arithmetic. So are you ready? So this is the solution. Remember, this is x sub 1, I'll write it, x sub 1, x sub 2, x sub 3, x sub 4. Now, x sub 4 was free, and you chose 4. So that's already been defined. But now, after we do this little bit of arithmetic, 1/4 of 4 is 1. So x sub 1 is 1. 5/4 of times 4 is 5. So that's your x sub 2. And 3/4 times 4 is 3. That's your x sub 3. Look at what you've just done. If you go back, are you ready? So 1, 5, 3, 4. If you go back to your original equation, if you plug 1 in here, 5 in here, 3 in here, 4 in here, you will have balanced this chemical equation, and you will have done so without all the guesswork. A systematic approach to balancing chemical equations can be done with the help of linear algebra. Now, I agree with you that we may have been able to arrive at that faster than all the work that we just did, right, using the guess technique. But you also can imagine that as your chemical equations get harder, they're going to become tougher to balance by guessing. But this method is not going to fail you. Anyway, so this is the first video. Just wanted to give you an application, giving some of the skills that we're developing. And when we get back, we'll start some more theory, and then we'll get to some more applications soon.